If you watch my video on display calibration at the end, I always recommend that you run a profile validation report whenever possible. This profile validation report is going to give you a lot of delta E values, which roughly describe how accurate the colors that are being showed on your display is compared to the reference value. Although I've gone over delta E in many of my videos, I never really discussed delta E extensively in terms of how that comes about, how's it being calculated, and what does it really mean to have all these values, and when, most importantly, do we start to see a difference in all of these delta E values? We're going to find out in this video. I'm Art, and Art is right. Before we start, subscribe if you're new and hit on the bell icon so you'll be notified every time I upload cool new videos like this. Before we can talk about delta E, we need a brief understanding of what happens during display calibration. I have the X-Rite Color Checker Classic pull up, and all of these patches represents a color in different color spaces. Right now, we're using the RGB value, and all these RGB values are based on the sRGB color space. These values can also change if I decide to represent this with Adobe RGB, CIE Lab, or even CIE XYZ, which is like the master color space. Every time I mention or refer to reference color value, I'm generally referring to the measured value that is using to reference all these colors. In this situation, we are using CIE Lab. So you will see there that this red, green, and blue at these values are representative of a CIE Lab at the following value. And you will see that respectively on the green and the blue as well. What's happening during the calibration is that our colorimeter or color spectrophotometer on the screen is measuring these values, and it knows that the colors flashing on the screen is supposed to be the value that you see there. However, the measurement value, which is the next column over, is showing a value that is slightly off. This is normal for any calibration because you need to know first what is it showing and then make the adjustment accordingly. The adjustment that happens at the end here, this is what's happening in a color calibration. So you will see that, for instance, it's supposed to be 42 and the adjustment is 41. The A in this red is supposed to be 53, but this is 54, and the B is 28 and is 27, so on and so forth. Making a color adjustment in the ICC profile or making a color adjustment this way is very similar to editing or doing color correction in Photoshop using the red, green, and blue channels separately. Every time you change one, it's going to change the other. So as you will see, the value doesn't land exactly where it needs to be, but it comes really close. And this closeness is what we describe the delta E value. So in a software calibrated display, I want to go in on this a little bit further. It will generate an ICC profile. The ICC profile will change the output and remap the colors that are coming out from your video card, is remapping that signal so that the colors that you're seeing on the screen matches closely or as close as possible to the reference value. Many times when you're running a software calibration, this is something that can happen, meaning that you will have tonal compressions and tonal expansion because there is signal manipulation coming out from the video card. In a hardware calibrated display, however, the adjustment is all done at the panel level with a dedicated hardware and a chip that does the color adjustment specifically. That's the difference between software and hardware calibration. But the principle of what's happening with these adjustments is very similar to each other. So what is delta E then? Well, delta E, as I mentioned before, is the value, compute the differences between all these values, and it comes up with one singular number. So you're no longer comparing three different values on these XYZ coordinates that are orthogonal to each other, but rather you're just comparing one singular value. And that's pretty much the idea of what delta E is in a display calibration. And normally the way how delta E is being computed, it's not so much with the measured value that you get, but is comparing the reference and the adjusted value together to arrive at that delta E value. This is, for example, what a calibration report looks like in i1 Profiler. It will tell you different delta E values, and you can set the different standards for them. This is a calibration or a validation report on an X-Rite palette master element. And this is the exported i1 Profiler validation report, very similar to what you see, but this will list the RGB value, the target lab value, and also list the measured value for three different color spaces too, the LAB, the XYZ, and also the UV color space. And it will give you a delta E at the very last column. Now that we have a brief idea of how display calibration works and where that delta E value may have come from, let's further discuss it. Starting with the delta, which is a mathematical symbol that describes the variation between two different values. The E itself comes from a German word, Erfindung. I apologize to any of my German viewers if I pronounce that incorrectly, but essentially that word in German roughly represents sensation. So essentially, it's a measurement or a variation between sensation or the way how we perceive color in this situation. This standard was put together by CIE, the Commission on Luminance, or as I will also try to pronounce this word, maybe incorrectly, so again I do apologize, Commission Internationale de Éclairage, which is the Commission on Luminance, which is the basis for all the colors that we are using today, the CIE lab. This is, they're known for it. So anyway, they have come up with this delta E in 1976 to describe the differences between different values and how we can compute how accurate color is. Throughout the years, there are a few delta E standards that have come out, with the latest one being delta E 2000, which take into account all of the luminance value, and this is supposed to produce a delta E value that is more accurate compared to any of the ones that have come before it. This is the formula that your software is using to compute and calculate the delta E value. Some of these symbols I can make sense of and I have a rough idea of what they're doing. Some not so much, but it really just depends on that. But what really this is doing is measuring how far off the colors that is being showed on your screen is compared again to the reference value, as I said earlier. On your display validation report, though, you will see two types of delta E value, one of them being the delta E average, the other one being the delta E maximum. The delta E average is going to be the average of all the values that are being measured on that report card. So if you load in a different chart, the average delta E is going to be different based on the delta E values for all those individual colors that are being measured. The max delta E will tell you that usually there is one or two colors that has a very high delta E value or a higher delta E value than the rest of the group. When you have that happen, you have the max delta E, and the max delta E tells you that for certain colors, this is going to be the max delta E for your screen, and that's just something to be aware of. So now that we have a better understanding of delta E, at what delta E value then should we start to worry about colors not being accurate? For our eyes, generally a delta E value of less than 1, we can't really tell the difference. A delta E value of 2, sometimes we can see a difference, sometimes we cannot. But what I have here is a software from a company called Babel Color, and it's called CTNA. This is a color measurement software to have, and you can download the trial version to play around with it. In fact, I'm using the trial version to do this demonstration for you right now. So for this delta E color demonstration, I'm going to show 4 different colors, red, green, blue, and also I'm going to take a color from the Color Checker Classic, which I used to run a profile validation on Xray i1 Profiler, and also dial that value in too. So let's first start out with red. Right now, I have 2 sides of red, both represented by Adobe RGB 1998, so both of them are now looking the same, and the delta E value I'm using here is 2000. Let's start to vary the second value. I'm going to bring this down to a delta E value of 1.21, and for me right now, I'm able to see the differences between the two when they're side by side with each other. However, if you come and click here and you start to divide them by putting the gray around them, as you see here, I can't really tell the differences between them anymore. Especially if they're smaller, it's even harder to tell the differences between those two. If they're between black divided like that, it's really hard to see the difference, or even white. So the only time where you would really see a delta E variation is that they almost have to be like right next to each other, side by side. And that's something to always keep in the back of your mind too as you're running the edits, as you're calibrating your display, is that most of the time you won't be able to see the variations or whatever you're trying to compare to side by side in this manner. And this is really unrealistic because this is almost like a synthetic test to see how our vision is. In a real world image that we would bring in to do our edits, all the colors are generally going to homogenize. So what you're seeing here, it's not necessarily a true real world representation, but it does give us an idea of, if a delta E of 1.2, can we see a difference? Yes, but if they're further apart, can we see the difference? And just by that small gap there, we can't see the difference between them anymore. So these gives us a lot of food for thought in terms of how we are going to manage and, deal with delta E. Let's bring the delta E further up. So for example, at the delta E of 3, it's a little bit difficult to tell right now, but I can tell for sure that the one on the right, which is this one here, is darker than the one on the left. If I do this, it's a little bit hard to tell, but I can still tell that it's a little bit darker. Again, a little bit darker. And you can see really clearly that these two are two different reds now. You can see it right in there too. But if I bring this value down to about 2, or 1.83, next to each other, you can see it. Without them being next to each other, a delta E value below 2, it's really almost imperceptible to our eyes. Now let's try green. Again, using delta E 2000, I'm going to start to bring green down, and let's do it side by side so we can have a better comparison. So for green, what I'm doing right now is the delta E value differences between 1. I can see the difference between these two, and I can see somewhat of a difference there in the different comparison that is showing. However, again, if I split them up, a delta E value of 1, I can't really tell the difference unless they're right next to each other. So this just really goes to tell that our eyes can't really discern colors many times that well, especially when they're not standing right next to each other or up against each other. Let's bring this delta E value further down to around 2.24. Now we can start to see the differences between color a little bit clearer. If we divide them, a delta E differences of 2.24, well, you can probably tell that the one on the right, this one right here, is a little bit darker than the one on the left, but it's really hard to discern. It's really hard to tell. For instance, especially if I do this, I can't barely tell them apart anymore. So again, if you want to play with this, I think this is a great thing to do and just to kind of fine tune what delta E really should mean to you. But in most situations, what I will tell you right now is that a delta E value that you may see of 2, of 3, or something like that, you're going to be okay. And as I mentioned in many of my calibration videos, I also preface that a delta E value of anything below 5 for a display is considered good. Anything below 2 is considered fantastic. So, you know, something to think about as well. And lastly, we're going to look at blue. Again, I'm pulling blue down. Let's start with a delta E of 1.26. Again, side by side, very easy to tell. Start to split them apart. You can't really tell them that much anymore. So let's do this. Let's keep it on gray and let's increase the delta E value of blue to maybe 3.27. Can we start to tell at 3.27? I can probably tell that the one on the right is slightly darker, but it's really hard for me to see. And, you know, all the other ones too. But again, if they're next to each other like this, I can see a lot better. And I can see that this blue is definitely off with a delta E of 3.27. But again, most of the time, this is the real world scenarios. What we're going to be dealing with is based on different environment. So as much as you can be really concerned about a delta E value of 3 or a delta E value of 4, does it really make a difference? It really depends on the image that you have, what you're looking at, and how those tones are blending in and homogenizing together. And the last delta E color I'm going to show you is X-Rite Color Checker Classic, patch number 23, which is like this turquoise blue color. This is a calibration from BenQ PD3220U using the Xray i1 Display Pro. And what you're seeing here is a calibration done in sRGB color mode. So I'm just using the result from that calibration to do this demonstration. The average delta E for that calibration was 0.6. The max delta E though for this one specific color is 3.2. Everything else is below 1. So let's take a look at how this 3.2 really equates and how does that really play into our vision. So I have dialed the value in here using the lab value input for both of them. And if they're standing side by side this way with the gray in between, it's really hard to discern a delta E of 3.2. In fact, you have to look at on the side here that you can start to see that where we overlay the colors, you're going to start to see more of the color variations between the two. But if you're just looking at side by side that are farther apart like this, you can't even tell. For instance, if I space them even further apart, it's even more difficult to tell. This is on black, again, looks very similar to each other. They're off probably by slightly a little bit as far as my eyes can tell right now. But again, when I change to white, I'm starting to see color a little bit differently on each of the side too. And when you compare them between each other, you will see that it's more saturated on the left and less saturated on the right. This is a delta E of 3.2. But again, when it comes to real world images, should you really worry if you have 1 or 2 patched to our delta E of 3.2, delta E of 4? I say that it's not a big thing to be concerned with. As long as your average delta E is fairly low on the display, you're going to be able to get good results out of your image or anything that you're editing on your calibrated display. I hope that you find this conversation about delta E educational, fun, and helpful. Now that you know how delta E is being calculated and how it has come about from the calibration, you will also know that delta E is a really good overall indicator about the quality of the calibration or the quality of your display. However, it is not an absolute value. As long as you can calibrate your display and get a delta E value of anything below 3, I think you're going to be great. So what I would do with a delta E value is keep it in the back of your mind, be aware of what that delta E value is, but not worry about it too much. And every time that you recalibrate your display, your delta E value is going to change. It's going to vary slightly from verification to verification. So I would not worry about the overall delta E value too much in the color workflows you have, as I have demonstrated here. Anyway, if you have any questions about this, leave them in the comment section below. Give this video a like, subscribe if you're new, hit on the bell to be notified when I upload cool new contents like this, and until next time, ArtIsRight.